the second part is going to be the actual search algorithms, how we can find ourselves. The search algorithm is basically being done in two steps. The first one is to actually find the floor in the building, correct floor in the building, and then position ourselves on that floor. So as you can see from the scan that Jamon did, we do not use the actual signal strength of the access points that we see, but this values from 1 to 0. Well, not necessarily the 0 value, but they are organized in that interval. They actually show the interrelation between the access points and their strength, from where 1 is the strongest access point that we see in this location, and the lowest one is going to be the weakest one. So that's what we actually record in the database, and this is the raw data that we use to locate ourselves. From that point, I'll just show the slide. We are using two approaches, which was proposed by me, and the second one was proposed by Jamon. Oh, sorry. So both of them are pretty close, which means we use the same data, and there's slight difference in the results. Jorge's algorithm takes that data, and we organize the signal strength we spread it more in the interval from 1 to 0, depending on how many access points we actually see. So let's say if we have 5 points, the signal strength is not going to be the actual value that we record, but it's going to look like 1 for the strongest, then it's going to be 4/5 for the second strongest, 3/5 for the third one, and so on. And so it's going to be more spread out in that interval. My algorithm uses the data that we actually collect, so it actually saves the interrelation between the signal strength of the access points that we see. And the results pretty much are the same. The precision and variability is very close, but to optimize the estimated coordinate, we actually use combined estimate, which actually gives a better, smaller variance, which means better estimate. So that's pretty much why we see, while doing our search, we actually see 3 circles, which represent Jorge's algorithm, my algorithm, and combined one. This one, the red one, shows my algorithm. Jorge's green, and blue one is the combined one. In this case, green one has the best result, because we are located in this room. So why not use the green one as a result? The fact is that the blue one has the smaller variability, which means that by doing multiple scans, the consistency is going to be the best for the blue one, meaning that red and green could jump around more than the green one. So we would be better off using the blue one in this case. So this is how we use the basically statistical regression techniques, linear multivariate regression by well, that's how we use these techniques to estimate. In particular, we use the both algorithm. We use pretty much simple matrix transformations, which is we build our matrix using the signal strength for the current location, and then we locate the MAC address in the database, and we find all the previous scans that actually were recorded in the database that contain at least one of those MAC addresses for the current scan. So when that happens, we can build up similar vectors in the MAC space with the values of for the signal strength for all the previous scans on that floor, and this provides us with enough data to build a regression based on signal strength versus the actual position on that floor. That's why this is how we get the transformation matrix between the existing coordinates and the current coordinate that we're trying to estimate, and that's pretty much how we get the estimated coordinate for our position. So either
So I guess I would just add to that. It's like I don't know if it's at school. Probably many of you did regression, just linear regression, right? You get a cloud of points in a graph, and then you find the best line that fits all those points, and then you use that as the equation for the points. So this is basically the same thing, just the points are a bit more complex. They exist not in a two-dimensional space, but in a multi-dimensional space, because each dimension corresponds to one access point that we see around, right? So it can be 6 or 7 or 8 or 9 or 2, but that's the basic idea.
Exactly.
You get all the points around you.
all these points pretty much determine our space that we're trying to project onto the x and y space, on our coordinate space, and all these points are built up. They have exactly the same unit vectors, basically, which are our signal string for each of the MAC addresses. So we're trying to estimate our location based on the previous scans, which we organize in that space that we build up, and they're gonna basically that's how we get our regression. That's how we get our in this case, since it's multivariate, it's going to be transformation matrix, not just a simple linear equation. And this is how we estimate the position based on the previous scans.
So anyway, that's pretty much it. And
I can just show quickly again, like I didn't make it very clear when I first ran the application what was actually going on. So let me just find, let's say, the 7th floor of Robarts, or actually, and not going to work. I'll clear it. There we go. Okay, so I've got just a blank floor plan. I just want to show everybody how it determines, it looks kind of magically, the floor that we're on. So here's 7th floor, where Yura and I have been doing most of our scans. And as it's going, we'll just do a search, and it will pop up this floor. Like I said, this is really important information that we're able to provide a user. If nothing else, let's say you're getting off of an elevator in a building, and there's no sign telling you what floor you're on. Within 15 to 20 seconds, maybe faster, depending on if we can optimize things, we can give a user via screen reader or however else they would like to get that information. We can give them the floor that they're on. And there we go. That's a really good scan too. And again, we haven't collected any more data points compared to last time.
Just for the
so how many data points are in this floor?
I just did it yesterday just to see if this is going to work on this floor, and I pretty much just went, made 6, 7 scans where I know my current position, the scans that are going to be used to estimate the new position, and in the best case, yeah, it will require the more points we obtain on this floor,